First, I would like to go through our application flow. Here we have a NeuroSky device and an Android phone. They are paired through Bluetooth, and the NeuroSky device sends different signals to our mobile application. We're using Facebook APIs for user authentication, and the basic idea here is to predict the user's mood based on the signals received. So we have built a model for this in MATLAB. And we have tried to incorporate this MATLAB code in our Android app by using MATLAB coder and generating C code, and then using Android NDK to call the functions. But this was taking a lot of memory and all the functions weren't portable. So we had to use a fog server. And the fog server basically calls the MATLAB code from PHP scripts. In this, we just post our signal data using PHP scripts and then call MATLAB functions from the server's exec command in PHP. MATLAB processes the input data based on the training data available in the server itself and sends it back to the mobile device. Now we have the predicted mood based on our MATLAB model. We show it to the user and he can go along with it or he can change it if he's in a different mood. Now we add the final resultant mood back to the training dataset. This way, our training set keeps growing and gives better results. Now we use Musicovery APIs to get song names based on the current mood. Then we use SoundCloud APIs to stream this music for the user. We've used SoundCloud APIs because it's free. It can easily be replaced by a premium music service like Spotify or Last.fm. Our app also has a database which stores users' data and users' playlists data. Now let's move on to the mood prediction algorithm. We referred two research papers to build our mood prediction algorithm. First one is song-induced mood recognition system using EEG signals. In this paper, they have analyzed the change in moods due to listening to songs. Here they classified the signals based on the type of song the user was listening to. Here we can see the plots of different EEG signals based on the song they were listening to. And the next one is real-time EEG based emotion recognition and its applications. In this, they have proposed a fractal dimensional model for mood recognition. They have used a Higuchi algorithm to find the fractal dimension values of signals from different electrodes. They selected particular electrodes from left and right hemispheres and called their fractal dimensions as arousal and valence. And they've plotted the moods based on this arousal and valence values. It's shown here. This is a plot of emotions in the valence arousal system. For our app, we selected one mood from each quadrant. They also discuss about the EEG signals being different for different people even when they are in the same mood. Now for our prediction algorithm, since we do not have multiple electrodes to implement the valence arousal model, we combine these two papers to build a new algorithm. Since we know listening to music affects our mood and the EEG signals, we'll initially have a training phase. This happens when we run the app for the first time. It picks one song for each mood and the user listens to all the songs while wearing the headset. Now since we know the label and the FD value calculated from the Higuchi fractal dimension algorithm, we add this to our server database. This will be our initial training dataset. After the training phase, we use naive based classifier to classify the new incoming data and then add that back to the training dataset as mentioned earlier. By this way, the results keep getting better as the user uses the app. This is the MATLAB implementation for our mood prediction algorithm. This function calculates the Higuchi fractional dimension value for any incoming array X with a base Kmax value. Here we set it to 256 in our training and testing. And this is our training script where we get the EEG values along with the mood label. we just calculate the Higuchi fractional dimension value and then insert it into the database. While testing, since we only get the EEG values, we calculate the HFD and then apply a naive based classifier based on the available training data in our fog server.
Nehemiah 8:6 and Ezra blessed them.